Hey, I'm Nathan Loop, and welcome to my network automation course. In today's video, we are going to talk about GitHub and how to use it as a network engineer. And I can already see people's eyes glazing over at that first sentence. There's a lot of resistance, particularly among network engineers that I've talked to, with learning and using GitHub. And it ends up becoming a self-fulfilling prophecy where people are hesitant to use it and then they don't going forward. But I promise if you learn to use it and it's not hard, it's really going to make your life easier. Another objection that I commonly hear is, well, I don't write code with other people. Yes, I'll write some scripts here and there, but it's really just for myself. I'm not collaborating, and GitHub is for collaboration. Well, that's only one of the two main use cases of Git. Git itself is a program that just runs on your computer. And GitHub is really cool, and they offer a free service, and they let you store your Git files on a remote server, but you don't have to. You can just use it on your computer by yourself. And the main use case for this is something that I think applies to most people. So most people watching this video right now, I guarantee have a folder on their computer, and in this folder, there's going to be a file that they've been working on, whether it's something they were writing or maybe some configs or a script, whatever, just something they were working on. And you have file.txt. And you also have file old.txt, and you have file last week's date.txt, and you have all these versions of it that you've saved going along to try to keep old revisions of it. And without fail, as you're doing that, you forget to save one, or you delete it, or you overwrite it, and you can't come back to it, and it's a pain. Everybody has this. I do it, everyone does it. So what Git can do is Git can help solve that. And so think of it kind of like in modern word processors or even Excel, they have the autosave feature. So it can autosave as you go along, and you get all these revisions and history, and you can go back through and look. Well, that's what Git is going to do, except Git is even more powerful, and you're not limited to using an Office environment for it. You can use it for whatever you want, and instead of a single file, you can use groups of files. So it's really handy. And another common objection that I hear is, well, Git's really just for open source stuff. I don't want to be putting my stuff on the internet. It used to be that GitHub was only free for open source public repositories, but now you can actually do private repositories online, and those are free as well, and you can just store it on your computer. So it's really handy either way, and if you stick with it and learn, it doesn't take too long. It's really going to be useful for you in your day-to-day practice for more than just coding. So let's take a look and see how the system works. So Git is a multiple step process, and when I was first learning it, I didn't really understand why there were multiple steps, and it just seemed to me like I was doing more work than was necessary. But once I wrapped my head around the why of these steps, it started to make a lot of sense. So let's take a look at that and see why it's set up and what these steps are. So Git works in a timeline, and you have this timeline, and your timeline is called a branch, and you start in each entry on your timeline is a commit. So you have these commits, and these commits are all versions of the files you're working on. And the last commit, the very one that you're working on right now, is referred to as the head. So in this branch, this timeline, we have 4 commits, and Git refers to them by a 7-character string here. It's a hexadecimal string. And so those are our 4 commits that we've done. Each of these commits contains files. Think of it, it's almost like a zip file or something like that. So we might be working on some configs for Cisco. So we have our 3 different configs here, and there's different versions of them in each commit. So as you're getting ready to create a commit, Git is going to give you a separate area called a staging area. And this is what kind of threw me for a little bit of a loop at first, where why do I have to put things into my staging area and then I have to commit them? Well, your staging area is a working area. So say I want to change 2 of these. Say I want to change my 9000 Catalyst, my 9200 and my 9300 CFG files. Well, I don't want to do a commit for both of those. If I'm doing a commit every single time I save a file, my timeline is going to get really long and really messy quickly. So what Git allows you to do is have this staging area, and you can say, okay, I want to work on these 2 files or these 20 files, and once I'm going to put them all into a staging area, and then once I'm happy with how they are, then I'm going to commit it and put a new entry in my timeline with a new commit where I can go back to. So what this allows you to do is, instead of having all those files in that folder on your computer with all the old versions. Instead, you just have one file on your computer, but it's managed by Git, and you can use Git to go back and look at the history of it, and you can see. Or instead of one file, just one folder, and you can see all the versions of the files within that folder. So it's a really handy way to do it. So what happens though if you want to go back? So the main reason we keep all these versions of files is to go back, right? Because what if you made a mistake and you had a version that worked before and you wanted to see what it is? How do you go back? Well, there's two versions to do that. And two different use cases, and it also took me a little bit to wrap my head around the why of that. So if you're working just by yourself, you can use what's called git reset. Say you have 6 different versions of your file here, 1, 2, 3, 4, 5, 6, and you realize that 4, 5, and 6 were a mistake. You are going down a rabbit hole, it's just not working. You want to go back to 3, and you don't care if you ever see 4, 5, and 6 again. They were bad code. So what you can do is you can use git reset, and git reset will make it like those never existed. So you can take those and you can just wipe them out. So you were at 1, 2, 3, 4, 5, 6. Nope, we're just going to go back to 3. Those other ones never existed. So if you're working on files locally, git reset is fine to use. Just keep in mind that they're gone. They're gone for good. The other way to do it is git revert. So say you're working on those files and you like the code you wrote, but you're not going to use it right now. You still want to keep your changes, but you just kind of want to go back in time a little bit. What you can then use is git revert. And I think git revert is a handier way to do it, and it's what I use personally, and especially if you're working online, and we'll see why with that. But so with git revert, you have those same files, your 6 different commits that you've done, but you're like, I want to go back to 3. But I don't really want to lose 4, 5, and 6. I had some good work in there. Maybe I can use it later. Well, what git revert will do is git revert will just take 3 and stick it right onto the end of your timeline here, but you're still going to keep 4, 5, and 6. So you have that code saved in your history and you can go back to it, but it's not necessarily wiped out. It's still there for you to look at in the future. So those are the main concepts of Git, where you have your staging area and you have your commits. Your commits add to your timeline. And then if you want to go back, you can use revert or reset. There's a few other ways to go back in time, but we're not going to worry about those right now. These are kind of the main ones. And so this is Git on your local computer. Let's go ahead and take a look and see how we use this on both the command line and Visual Studio Code. Calling a quick audible here, and before we go and look at the GitHub workflow, let's take a look at how to get Git. It's pretty easy. It's a little bit different for Mac OS though. You go to the GitHub website, Git SCM, and when you go to downloads here, if you go to Mac OS, it's mainly done through Homebrew. So you want to download and install Homebrew, and then you can just do brew install Git. So that's a little bit different than the normal way on a Mac OS where you download a program and just drag it to the application folder. On Windows, it's going to be a little bit more straightforward. You can just download Git for Windows, your 64-bit there generally. And for Linux, it's going to be done through your package manager for whatever repo you're using. So that is how you actually have to get Git. It doesn't come with Visual Studio Code, so you will have to download and install it.